Welcome to the first video in which we are going to do an example on solving quadratic inequalities. So, let's say we have the quadratic inequality x squared plus 2x minus 25 is greater than or equal to -1. So this is the quadratic inequality that we have, and this is the quadratic inequality that we want to solve. Now, we said that the first step in solving a quadratic inequality is always to take this number to this side so that we have a 0 here. And so doing that gives us x squared plus 2x minus 24 is greater than or equal to 0. Yes, minus 24 is greater than or equal to 0. So this is the quadratic inequality that we now want to solve. Now, if you've been watching my previous videos, if you watched my most recent videos on quadratic functions, you will realize that this expression here that is on the left-hand side of the inequality sign is simply a parabola. It's a graph. And more specifically, this expression here represents the y-coordinate of our parabola. So for example, if our parabola is going to be like this, then this expression here gives us the y-coordinate of every single point on this parabola. So what this inequality is really trying to say here is, what are the values of x such that if I go to my parabola, my y-coordinates will be greater than or equal to 0. So the visual image is, if this is the graph that I have here, in what region of this graph is the y-coordinate of the graph going to be greater than or equal to 0? Assuming that this is the graph x squared plus 2x minus 24, what this really means is, where is this graph greater than or equal to 0? Remembering that this thing here is just the y-coordinate. So where are my y values going to be greater than or equal to 0? If I come into this region here, if I pick any x-coordinate of this graph in this region here, all my y values are less than 0, because this is where y is equal to 0. So if I pick these coordinates right here and I move down to where they touch the graph, all the y coordinates here are less than 0. But if I pick this side of the graph, this side of the graph is greater than 0. It's greater than 0. So all the x values on this side of the graph will satisfy this quadratic inequality. Same applies if I pick this side of the graph, this part of the graph. All the x coordinates here, which are on this region of the graph, are going to have y values that are greater than 0. So all these x coordinates here will satisfy this quadratic inequality. So basically, the solution to this quadratic inequality would be the x coordinates there and the x coordinates there. The x coordinates between this point and this point wouldn't satisfy that, because they would produce y values that are less than 0. But my inequality says I want y values that are greater than or equal to 0. So I pick these x coordinates and these x coordinates. So clearly, the first step in solving a quadratic inequality is to sketch the graph, is to sketch the particular graph and do this visual analysis in order to get the answer. So basically, the graph that I have here, the function that I have here is f of x is equal to x squared plus 2x minus 24. This is the particular function that I want to sketch on the coordinate axes so that I can do this analysis in order to solve this quadratic inequality. So this is where we need to apply our knowledge on how to sketch a parabola. So the first thing that I need to do in order to sketch this parabola is to complete the square in order for me to find the minimum point. And I already know the shape of this. It's going to be a happy graph, it's going to be a smiley graph, it's going to look like this, because the coefficient of my x squared term is positive. So if I complete the square for this, I will get f of x is equal to x plus 1 squared minus 25. So what that tells me is that the vertex of the graph is going to be equal to -1, comma, -25. So basically, our graph is going to look like this, and this minimum point here is going to be this -1, comma, -25. Now the next step in sketching this function is to solve this thing in a quadratic equation. We want to know where this graph cuts the x-axis, and to know where the graph cuts the x-axis, we're going to equate this to 0. We're going to equate this function to 0. We're going to solve the quadratic equation f of x is equal to 0. F of x is equal to 0. So we know that our f of x is equal to x plus 1 squared minus 25. So what we're really trying to solve here is x plus 1 squared minus 25 is equal to 0, This is what we're actually trying to solve. And what this implies is that x plus 1 squared is equal to 25. X plus 1 squared is equal to 25, so x plus 1 is equal to plus or minus the square root of 25. So x plus 1 is equal to plus or minus 5, and x is equal to -5 minus 1, and x is equal to positive 5 minus 1, because x plus 1 is equal to plus or minus 5, so it'll be plus or minus 5 minus 1, so it's -5 minus 1 and plus 5 minus 1. So -5 minus 1 is -6, so x is equal to -6, and x is equal to 5 minus 1. That's going to give us 4. So these are going to be our two solutions to this quadratic equation. So the solutions to the quadratic equation f of x is equal to 0 are going to be x is equal to -6 and x is equal to 4. So, and by the way, in case you didn't notice, I just solved this quadratic equation by using the completed square version. You could have gone to this original f of x function, factorized it, and solved it the normal way, or you could have used the formula. But you can also start from this completed square version and solve the quadratic equation from this completed square version, which is what I just did. So basically, now we know the shape of our graph. Now we can sketch our graph, where we know that our graph is going to look something like this. Is going to look something like this, where this is going to be 4, this is going to be the x-coordinate, x is equal to 4, and this is going to be x is equal to -6. So our graph is going to look something like this. Anyways, this brings us to the end of the first part on solving our quadratic inequality. In the second video, we are then going to do our analysis to actually figure out the solution to that quadratic inequality. Until next time.